Hey guys, Mosh here. Today we're going to talk about insertion sort. Insertion sort is one of the many sorting algorithms that come up in coding interviews all the time. In fact, these days more and more companies ask data structure and algorithm questions in their interviews to see if you can think like a programmer. In this video, I'm going to show you how insertion sort works and how you can implement it in Java. If you don't know Java, that's perfectly fine. You can still follow along and implement the insertion sort algorithm in your favorite programming language. Also, if you want to learn Java, I have a comprehensive 2-hour tutorial for you here on my channel. The link is below this video. So let's jump in and get started. The third sorting algorithm we're going to talk about is the insertion sort algorithm. A good way to understand insertion sort is to think of playing a card game. So imagine each item in this array represents a card. The dealer gives you one item or one card at a time. Every time you get a card, you insert it in the right position. First you get 8, you keep it. Then you get 2, you insert it before 8. Next you get 4, you insert it between 8 and 2. Then you get 1, you insert it before all the items. Finally you get 3 and insert it after 2. So every time you get an item, you insert it in the correct position. That's why we call this algorithm insertion sort. Now let's see this in action. So we get 8 and should find its correct position amongst the items or cards we have taken so far. 8 is the only item we have seen, so we assume it's in the correct position. Next we read 2. We should insert it before 8, but how? Unlike the previous algorithms, we're not going to do a swap here. Instead, we're going to look at all the items we have seen so far. If they're greater than 2, we should shift them to the right to open space to insert 2. This is a key distinction between insertion sort and other algorithms we have talked about. Instead of swapping items, we shift them to the right. You'll see why in a second. So 8 is greater than 2, and we should shift it to the right to open space for 2. To do this, first we store 2 in a separate variable called current. Next, we shift 8 to the right. Well, more accurately, we copy it to the right. So it overwrites 2. That's why we had to store 2 in a separate variable so we don't lose it. Now, technically we have stored 8 in 2 places in this array, but conceptually we can assume that we shifted 8 to the right, so now the item at index 0 is empty. So we stored the value of the current variable here, okay? So we inserted 2 in the correct position amongst the items we have seen so far. This is the sorted part of the array. In every step, we pick one item from the unsorted part and insert it at the correct position in the sorted part. So next we read 4. Now we look at the items we have seen so far. If they're greater than 4, we shift them to the right to open space to insert 4. So here we shift 8 to the right. Now what about 2? Should we shift it to the right? No, because 2 is smaller than 4 and it should stay where it is. So we have found the right place to insert 4. All the items we have seen so far are in the correct position. So next we read 1. Again, we should shift all the greater items to the right to open space for 1. Here we should shift 8, 4, and 2 to the right because they're all greater than 1. Now we insert 1 in the correct position. We're almost done. One more time. We read 3 and shift all the larger items that we have seen to the right. Now we insert 3 at the correct position, and we can see our array is fully sorted. So this is insertion sort. Now let's do time complexity analysis. Here we need to iterate over the input array and read one item at a time. That's an O of n operation. In each step of the iteration, we need to iterate over the items we have seen so far and shift them if required. In the best case scenario, if the array is sorted, the current item is already in the correct position, so we don't need to shift any items. That's an O of 1 operation. In the worst case scenario, where the array is sorted in descending order, we need to shift all the items we have seen to the right because the current item is smaller than all those items. That's an O of n operation. So the time complexity of insertion sort is O of n for the best case scenario and O of n squared for the worst case scenario. It's the same as bubble sort. Now spend 20 minutes and implement this algorithm on your own. Then come back see my solution. Just like before, let's add a new class called Insertion Sort. In this class, we need one method, public void sort, which takes an integer array. Now here we need to iterate over this array and insert each item in the correct position. So we need a for loop. We start from index 1 because as you saw in the previous video, when we read the first item, we assume it's in the correct position because there are no other items that we can compare this item to, okay? So we start at the second index. As long as I is less than array.length, we increment I. Now here we store the current item in a variable called current. So we set this to array of I. Then we need another loop to look at all the previous items, and if they're greater, we need to shift them to the right. We can use a for loop or a while loop. In my opinion, a while loop looks better here. So let's say our loop variable is j. We set it to I minus 1. We start from the previous item. Now, as long as j is greater than or equal to 0, and the item that we have at this index is greater than the current, then we need to shift this item to the right. So we set array of j plus 1 to array of j. So we copy the item at this index to the right side, okay? And then we decrement j. So after this while loop, all the greater items have been shifted to the right. Finally, we can store the current item at index j plus 1. So array of j plus 1 equals current. Now let's test our implementation. So back in the main class, I'm going to replace selection sort with insertion sort. We have an empty array. Let's see if everything works. No problem. What if we have a single item? So far, so good. What if you have 2 items? They're sorted, beautiful. What if we have a few more items with some duplicates? Our array is sorted in ascending order. Beautiful. Hey guys, Mosh here. I wanted to let you know that this video is actually part of my Ultimate Data Structures and Algorithms course. The complete course is 13 hours long, and I've divided it into 3 parts so you can take and complete each part easily. If you're serious about learning data structures and algorithms, I highly encourage you to take this course and learn all the essential data structures and algorithms from scratch. It's much easier and faster than jumping from one tutorial to another. We'll be talking about various types of data structures such as linked lists, stacks, queues, hash tables, binary trees, AVL trees, heaps, tries, graphs, and various types of sorting, searching, and string manipulation algorithms. The course is packed with almost 100 interview questions. These are the interview questions that get asked at companies like Google, Microsoft, and Amazon. You can watch the course online or offline, anytime, anywhere, as many times as you want, and you would also get a certificate of completion and a 30-day money-back guarantee. It's exactly like this tutorial, it just has more content. If you're interested, click on the link below this video to enroll in the course. Thank you and have a great day.